Hi students, this is Dr. Joseph from Christian School of Management. In this lecture, we are going to see about regression analysis using Python. So first we'll learn about what is regression and under what circumstances and for what reason we use regression, and then we'll see a program in Python to run a regression. So first let me explain the concept of regression. So regression, we are talking about the simple linear regression. We need to know this equation, the linear regression equation, which we write it as y is equal to mx plus c, which is also called as the equation of a linear straight line, and wherein the y is the dependent variable, x is the independent variable, and m is the slope and c is the constant. So x is our independent variable and y is the dependent variable. So here more often what we understand from here is, if you know the values of m and c for any values of x, you can predict the value of y. So that is the concept. So for just to understand the concept of equation of a linear straight line, I assume m is equal to 1 and c is equal to 1. So both the values of slope and constant are assumed as 1. I am going to take different values for x, so that when I substitute the value of x in this equation along with the assumption of m and c, we can get the value of y. So we'll see how we can do it. So here on the left hand side, I have a small table with the variables x and y. So already the x variables value are given starting from 0 to 5. And we are going to calculate y, or we are going to predict y using this regression equation. For the first case, x is 0, so m is 1 and c is 1. 0 into 1, so that will be 0 plus constant is 1, so y will become 1. Next scenario, x is 1, so here the value will become 2. X is 2, y will become 3. X is 2, y will become 4, x is 4, y will become 5, and x is 5, y will become 6. I hope you get this. If I substitute the value of m is equal to 1, x is equal to 5, and c is equal to 1, the value of y will become 6. So this is how, like, if you know the value of m and c, for any value of x, I can predict the value of y. This is the entire concept. Just to show you, I'm going to plot this x and y in the form of a graph. Scatter plot. So I'm plotting x and y here. Now if you look at this, when x was 0, y is 1, x was 1, y was 2, when x was 2, y is 3, when x was 3, y is 4, when x was 4, y is 5, x was 5, y becomes 6. So when I plot this, you can see here all the dots are on a straight line. So that's how we got this equation. We call this as the equation of a linear straight line. So this is a linear straight line. If we change the value of m or the value of c, so the slope of this linear straight line will go to left side or to go to the right hand side. It will go up or it will come down. This is how the linear equation is written for a straight line. Now in business, what we try to do is, so we are discussing simple linear regression. So we have one dependent variable and one independent variable. So if you have two variables and if you plot those variables values in a form of a scatter plot, so say for example, I have a plot here with I have plotted both x and y. So it will be like scatter plot, all dots are there. So if I have to connect all the dots with a straight line, it is impossible. Values or the data points are scattered. So what we try to do is, we try to do an approximate straight line in such a way that all the dots are represented in that straight line approximately. So if I draw a line, the line would look like this, and again it's a linear straight line. We know why we are approximating is, we know the equation, we know the mathematical representation of a linear straight line. So in say for example, in a real-time case, rainfall, which is a continuous variable, which is an independent variable, so we can take it as x, and on the other side you have the sales of umbrella, a product, which is the dependent variable. So on the y, which is our dependent variable, which is the umbrella sales, x, which is going to be the amount of rainfall, If I have to find out, if I have to predict the umbrella sales based on the forecasted rainfall, then what I can do is I can take the old data of rainfall and the sales of umbrella. I can plot it into a scatter plot like this. And if I draw a approximate linear straight line, and I can represent this straight line in the form of a mathematical equation in the format of y is equal to mx plus c. And once I do that, for any value of rainfall which is x, with the known value of m and c, I can predict the value of y. So that is the concept. So in this lecture, we'll see simple linear regression. In the sense, we'll take two variables which are continuous in nature. One will be the dependent variable, the other one will be the independent variable, and we'll try to see how we can run the regression and find the regression equation, so that for any value of x we can predict the value of y. So regression analysis, we know that it comes under supervised learning technique. Supervised learning technique, the data will be split into two parts. One is the test data set, the another is the training data set. So we'll either we can do a split and then run the regression for training and then for testing, or in the program what we have done is we have taken all the data points of the past data and we are using it for training, and with that same data point and with the obtained linear regression equation, we try to predict the y value with the equation, and then we try to see whether the prediction and the actual value are the same. If the predicted values are highly deviated from the actual value, then the accuracy of the model reduces. If the predicted value is very close to the actual values, then the errors are less, so the model will be really good. So that's what we'll try to do. So for this, we are going to use a data set called automobile, which is in the form of a CSV file, and we try to take two variables from that particular data set, and then we'll try to run regression. So I have my program in Google Colab. So let me explain the program first and then we'll see how to run it. So first step, we are importing all the libraries. We are importing 4 libraries. One is importing the matplotlib pyplot as plot. Matplotlib, we know that it's used for creating plots, and here we might be using a scatter plot to see the regression plot. For that we need matplotlib, and then numpy we are using it because the data is in the form of a data frame, which is the rows and columns, but we would require only 2 columns. If it is 2 separate columns, it will be treated as a single dimensional array. So in order to create an array, we are going to use the numpy, and then we are going to import the function linear regression from sklearn.linear model. The linear regression function is used for running used for both testing and also training. The pandas library for reading the data from the CSV file and converting that into a data frame. So 4 libraries we are going to import. So the second step is to read the data from the CSV file. So the CSV file name is automobile. So we need to use the file name along with the extension. So CSV is a comma separated file. So automobile.csv is the name of the file which we are going to use. And always we know in Python, the left hand side is the user defined term. It's not a keyword. And we have auto is equal to pd.read_csv. So the read_csv is the function which is inside the library pandas, which we imported it and abbreviated as pd. So pd.read_csv, and within the bracket we are passing the CSV file as an argument, which is automobile.csv. Remember that we need to mention it under a quotation mark. And then auto.head is just to display the table to understand the different columns over there. So before we go to the third step, I'll show you the table and then you can understand the different columns there. So before I run this, first of all, I need to upload the CSV file to the Colab environment. So let me upload it, and then so here we have the automobile file. I am uploading it. So now you can see on the left hand side the automobile CSV file is uploaded, and now I'm going to run only the first 2 steps just to show you. So here we have its automobile table. So the different automobiles brand names are given here under the variable make, and then a lot of variables there, but to run regression we need the variable which are integer or continuous in type. So I'm going to take two variables. One is called horsepower, and another one what I'm going to take is the mileage provided by the car inside the city, which is written as the variable name city underscore mpg. We can see in the third step, the first one what I'm going to take is the variable horsepower. Again, the left hand side is a user defined one, hp is user defined, not the keyword, is equal to np.array. So np is the library numpy which we downloaded, imported and abbreviated as np, and then array is a function which is inside the library which is used to create an array. So when you create an array, we need to pass the values. So instead of passing the values, what we are trying to do is we are trying to take the column called horsepower inside the data frame auto. So that's what we saw here in the output here. Horsepower is the name of the column. This spelling should be correct. So I have written auto.horsepower. So this entire column of values will be passed on to this function array as an argument, and that will be converted into a array. And then we use dot reshape -1 1. As of now, it's a two-dimensional data frame. From that, we are going to create it as an array. So we need to use this function called reshape. This will create an array with single column and with multiple rows. That's the why we are using -1 1. If we use 1 comma -1, it will create an array with a single row with multiple columns. So the reshape is used to shape the array in such a way that whether we want it vertically or whether we want it horizontally. Same thing I'm using it, same line, and only thing is I'm going to store it in the name of mpg. So mpg is again going to be an array. And here I'm going to take the variable name city underscore mpg, which is there in the table. So both the variables horsepower and city underscore mpg are continuous or integer type of data, which I am going to convert into the array hp comma mpg. So this is how we define the feature matrix. Then for training, before we do the training, what we are going to do is the function linear regression. This is the function. It's quite lengthy, so what we are going to do is we are going to assign that function to a smaller term called as model. That is again not a keyword, user defined. Instead of writing linear regression dot fit here for the training, what I'm going to write model dot fit, because I have assigned the linear regression function to the name model. So I'm going to use model dot fit. So fit is a function inside which is built inside linear regression. To this function, I'm going to pass the two array what we have created. One is HP and MPG. So both. So here I forgot to tell you that mileage given by the car depends on the horsepower of the car. That's what I'm going to test. So mileage is going to be my dependent variable, which is Y, and HP is going to be my independent variable, which is X. So when you pass the variable to the fit function, it will be fit bracket x comma y. So first independent variable comma then dependent variable x comma y. So here in this case HP is my independent variable, mileage is my MPG is my dependent variable. So I am passing those two arguments. So this will train the model and it will compute the linear regression equation. So we need to get, in order to get the linear equation, in order to construct the linear equation, we know that we need the value of slope m and also the constant c. So for which we are trying to extract the parameters from the model. One is the regression coefficient, which we would require to understand to what extent this model can predict the dependent variable. Again, the left hand side is user defined. So coef stands for the coefficient of regression, coefficient of determination, or the regression coefficient. So I'm just abbreviating it as COEF, coefficient. Model is what we assigned, which is linear regression over here. So model.score, model.fit we used for training. Now model.score we are using it to calculate the regression coefficient. Again, I'm going to pass both the array HP comma MPG. This will calculate the regression coefficient and it will assign to the variable COEF. Second is constant, which we also call it as intercept. So I'm using the term intercept here, and I'm using the same function model dot Now instead of score, I'm going to use intercept followed by an underscore symbol, which is the keyword. Without underscore symbol, Python will not understand it. Whereas on the left hand side, the intercept is the user defined one. You can also keep it as constant or simply as C, not a problem. And then slope, which is M. So slope, same function, model dot. Instead of intercept underscore, I'm using coef underscore, which is a keyword. Whereas on the left hand side, the slope is my user defined one. So this particular step will compute three variables. One is the regression coefficient, second is the slope, second is the intercept constant, and third is the slope, which is the M value. So once you compute it, we are going to print all those things. So print coefficient of determination. I am passing the value. Coefficient will come in decimals. We need to always multiply it with 100. And then second one, I am printing the intercept value, which we calculated in the second line. And then I am printing the value of the slope. So this will give us the parameters and with which we can construct the regression equation. So this, so far we have done the training and we have got the linear regression equation. Now when we do the testing, we are creating another variable called y predict or y underscore pred. Again, left hand side is user defined. You can have any variable. So the actual y is, we know that actual y is mpg, the array what we created. But we are going to, using this regression equation, we are going to predict the value of y for each and every values in the HP. So here already we have the old data. For the first one, the car has got 111 as the horsepower, whereas the city mileage is 21. The third one, the horsepower is 154, but the city mileage is reduced to 1919. So this is the actual horsepower and actual city mileage. Using this only, we construct the regression equation. Now what we are going to do is we are going to do the prediction. How we are going to do the prediction for the horsepower is, we are how we are going to predict the city mileage is, we are going to use the actual values of the horsepower and we are going to substitute this as the value of x in the equation y is equal to mx plus c, and we are going to calculate the predicted value of mileage, and that we store it as y predict. So for each value of HP, the program should compute y predict. So that is the testing part. So first we run y predict is equal to model.predict. For training we used model.fit. For predicting we are using model.predict. And when we did the training, if you remember, we passed both the variables. I said x comma y, it is HP is x horsepower, mpg is city mileage, which is mpg. Whereas when we do the predict, we are predicting the value of y. So we have to pass only the value of x over here. So the predict function will take only one argument, which is the independent variable, which is x. In this case, it is horsepower. So now the model, what it will do is it should take each value of HP from the table and it should substitute this value in the regression equation what we have created, and then calculate the y prediction, corresponding y prediction. So in the program, I have created a function here. So in this step, so we know that function definition start with the keyword def. My func is the name of the function, and then I'm going to pass the array which we created HP, and then inside the function, so here I have the indentation. Inside the function, I use the keyword return to return the calculated value. So what I'm going to do the calculation, I'm going to write the regression equation, which is slope into HP plus intercept. So slope already we calculated, intercept also we calculated, which is the constant. HP alone to be taken from the table, and using this formula it will compute the value of y predict, and then it should return that value. So this is the idea of the function, only 2 lines. So this is function definition. We know that the function has to be called, and the function can be, why we are using the function is to do the repetition or to reuse the code. So this calculation slope into HP plus intercept should be reused for all the values of HP in the data sheet. So for that we are using a function called as map. So we'll go from right hand side to understand this. So the map function has got 2 parameters. One is the name of the function, comma the variable which needs to be iterated every time. So here we have the HP values, which is an array, a list of some 400 items of different HP horsepower is there. So each time when I call the function, the program should take, for instance, the first time it should take the first value of the HP in the table. Second time it should take the second value of the HP in the table. Like that, the 400th time it should take the 400th value of HP from the table and then calculate Y predict um, for each and every value of HP. So that is the idea for which we use the function map. So map function will have two parameters. One is the function name, another one is the name of the variable which needs to be repeated. Okay, so here my func is the name of the function, HP is the name of the independent variable. So we are using the map function to compute it, and once you find the value of Y predict, what we need to do is we need to combine it to form it as a list. So it's not only one value, this function will not be executed for one time, it will be executed for all the items in the list in the table. So imagine if there are 400 rows in the table, this will be run 400 times, and in each iteration one HP value will be taken and this will be computed, and as it computes it will be converted into a list. That list we are storing it as my model. Okay, so now the my model is the new value of our Y variable, which is our mileage, which we are predicting it. And once you do the calculation, then we are printing the output. So for that we are plotting two scatter plots. The first scatter plot, which we take the actual value, which we take the HP, which is X, and we take the actual city mileage, which is MPG. And in the second plot we take the actual value of HPG, but here we are going to take the predicted value of Y, which has been stored in the form of list in the name of my model. So the my model is the one which is Y predict, or the predicted value of city mileage, which I am passing it to the second scatter plot. So now when we run it, we'll get two scatter plots. The first one will be the actual X and actual Y. The second scatter plot will be the actual X and the predicted value of Y. Let me run the entire program. So now here you can see here the first plot, the blue color one is our actual value of actual plot with the actual values of HP and the actual value of city mileage, whereas the second plot is the actual value of the city HP and the predicted value of the city mileage, the orange color dot. So that comes as a linear regression, a linear straight line, whereas the actual plot is actually scattered all along. So this is the approximate line, which is the regression line what we have plotted here, and you could see here the slope top to bottom that indicates that as the horsepower increases, the mileage keeps on reducing. That's the relationship we can infer from this. It has got an inverse relationship. Let us see the values also. So these are the computed values. The first one is the coefficient of determination, which the value has come as 67%. Remember, we multiplied by 100, so it has come as a percentage, 67%. It means the changes in the dependent variable, which is city mileage, the changes in the dependent variable are explained up to 67% only. The remaining 33% of the changes are not explained by our dependent variable, which is our independent variable, which is our horsepower. The point here is mileage does not only depend only on horsepower. Mileage depends on various other variables, not just the engine's horsepower. It also depends on how the driver drives, the road conditions, the driving pattern in the the case, like how he changes the gear in the right moment, how he accelerates, how he decelerates, the braking. So it depends on various other parameters, but in our model we have taken only one variable, which is our horsepower. So what we say is the mileage depends on only one variable, which is horsepower. In reality it is not the case. That's why the changes in the mileage is explained up to only 67% by the horsepower. The balance 33% might be of different any other reason other than the horsepower. So generally in academic research, if the coefficient of determination is above 60, it is accepted, but in industrial research they might require further very high level of coefficient of determination, like 80%, 90, 95%, or even 99%. So otherwise the model is not going to be very accurate. And that's why in the diagram also you can see here the orange line is not actually connecting all the points. It's an approximate point. For instance, for the value of 250 horsepower, the actual value of mileage what they have got is around, say, 15 kilometers per liter, whereas the predicted value for this 280 point is the predicted value of mileage is hardly like 2 or 3 kilometers per liter. So that is where the inaccuracy comes into picture. So that's why our model is only 67% accurate, we can say. The intercept value, the constant value is given. Slope is given here, minus 0.14. Why there is a minus is we have a negative slope that indicates that these two parameters are inverse relationship. If the horsepower increases, the mileage will reduce. So that's what the slope with the negative number we have got. So this is how we run the regressions using Python, one of the supervised learning technique. Thank you for watching. Please join me in the next lecture. Bye bye.